Lesson 32, simplifying and evaluating expressions with integer and zero exponents. So as a review, when we raise a base to a power, it makes the number bigger when you have an exponent bigger than 0. So 2 to the 4th would be 16. 2 to the 3rd is 8. 2 to the 2nd is 4th. You can see when we get the exponent smaller and smaller, our value gets smaller and smaller. Anything with an exponent of 0 is always 1. Now look what happens when we have a negative exponent. When you have a negative exponent, your answer is never simplified until you make that exponent positive. And to make it positive, we would have to do the reciprocal of the base. So the reciprocal of 2 is half. And then once we do the reciprocal, that means the exponent is now positive. So if we look over here, the reciprocal of 2 is half, or you can put it as 1 over 2 to the first power. It's a positive first, which anything to the first power is just itself, so it would be half. If you go to 2 to the negative second, the reciprocal of 2 is half, so we would have 1 over 2 squared, which is 1/4. And so we have, you can't have your answer with a negative exponent. So in order to get rid of the negative exponent, you have to flip the base. So let's take a look at some examples here. Again, here I said the expressions are not simplified if it contains negatives or a 0 exponent. And so we need to rewrite an expression with negative exponents by writing the reciprocal of the base and then write the exponent as a positive. So here I have x to the negative 3. So the reciprocal of x is 1 over x. And since I now have the reciprocal, my exponent is now a positive 3. So that would be my answer, 1 over x cubed. This next one, I have y to the negative 4th divided by x squared. I can't have a negative exponent, so I need to write the reciprocal of that, which would be 1 over y, and then I have the positive 4. And my x squared is already positive, so it has to stay put. So if it's already positive, you keep it where it's at. So my answer would be 1 over y to the 4th x squared. And the last one, 1 over y to the negative 4th. The reciprocal of 1 over w is w, and then now it's positive 4. So the answer would be w to the 4th. So if the negatives in the denominator, bring it to the top for it to be positive. Other ones, x to the negative 9th, reciprocal of x is 1 over x. This will make it a positive 9. Next one, d to the negative 2nd over c cubed. The reciprocal of d would be 1 over d. This would be squared. And then c cubed is already positive, so it stays in the denominator. And then the last one here, 1 over a to the negative 5th. The reciprocal would be a, with a positive 5 as our exponent. That's what the negative exponent property and the 0 exponent property would mean. For every non-zero x to the negative number, you do the reciprocal of the base to change it to its positive. Next one, x to the negative 5th. Reciprocal would be 1 over x. This would be to the 5th. Next one, p to the negative 8th divided by q to the 4th. I need to do the reciprocal of p to the negative 8th, which is 1 over p, positive 8. And then q to the 4th stays in the denominator. And this one, reciprocal would be d with a positive 8. Now these next ones, they want us to substitute numbers in and then simplify it. So a to the 2nd, so I'm going to have a negative 2 in for a squared, and then b is negative 3 to the 0 power. Now, we only do the reciprocal if the exponent is negative. So negative 2 squared gives us 4. Anything to the 0 power is always 1, so it'd be 4 times 1. This will give us an answer of a positive 4. Next one, 3 times b to the negative third, so I need to have b. b is a negative 3 raised to the negative third times negative 3. So if I were to simplify this, I need to do the reciprocal of negative 3, which would be, so it would be 3 times 1 over a negative 3, then that's cubed. Everything will be cubed, so the 3 would be cubed. I'm just gonna put the cubed up here, and then times a negative 3. So a negative 3 cubed would be 1 over 27. This would be a negative 27 times a negative 3. I can do some simplifying here. I can divide a 3 here and get 1, divide a 3 here and get negative 9. I can divide negative 3 here, get 1, negative 3 here, get a positive 3. So my answer would be a positive 1/3. Next one, a is 7, or negative 7. So negative 7 to the 0 power times b, which is negative 4 squared. So now I have anything to the 0 power is 1 times negative 4 squared is a positive 16, gives us an answer of 16. And the last one here, we have 8 times b, which is negative 4 to the negative second power times negative 4. So here we have 8 over 1 times 1 over negative 4 squared, which would be positive 16, times 4 over 1. I can do some simplifying here. 8 divided by 8 is 1, 16 divided by 8 is 2, 2 divided by 2 is 1, 4 divided by 2 is 2, so our answer would be 2. Other problems here. A to the 0 power. So to save time, anything to the 0 power is going to be 1. So I'm just going to put this as 1 times our b, which is 6, times our c, which is 3 squared. So 3 squared is 9. So I have 1 times 6 times 9, which gives us an answer of 54. Next one we have 4 times a, which is 4 to the negative second, which really, if I rewrote this, this would be 4 over 1 times 1 over 16. And that would give us an answer of 1/4. The quotient property of exponents. Just when we went through multiplication property of exponents, when you multiplied like bases, you added the exponents. Well, when you divide exponents, or divide bases, you subtract the exponents. And when we do this, we gotta make sure that our answer only has positive exponents. So if I take this first one on the bottom here, x to the 7th divided by x to the 3rd. To solve this, I would do x to the 7th minus 3. So I subtract the bases, and I would have x to the 4th. And that would be my answer there. Next one over here, I would have x to the 3rd, and I need to subtract x to the negative 7th. When I'm subtracting a negative, I'm really adding a positive, so our answer would be x to the 10th. And this last one here, I'm going to bring this one over here so I have a little more room. So I just take all my exponents, so I have x to the negative 5th minus 1. I have y to the 6th minus 2. And then I have z to the first minus a negative 3. So now if I simplify this, right now I would have x to the negative 6th, y to the 4th, and z to the 4th. But since I have a negative exponent, I want to write it so I don't have a negative exponents. So this x to the negative 6th has to be down on the bottom, the denominator, to make it positive. My y to the 4th is positive, and my z to the 4th is positive. So that would leave me with the answer of y to the 4th, z to the 4th, divided by x to the 6th. So this would be my answer. Next one, x to the 9th divided by x to the 6th. So I need to subtract my exponents. That would give me x to the 3rd. Next one, I would have x to the 9th minus a negative 6, which would give us x to the 15th. And over here, I have x to the 1st minus a negative 4, y to the negative 6th minus a negative 5, and z to the negative 3rd minus 1. And when I simplify it, I end up with x to the 5th, y to the negative 1st, and z to the negative 4th. To rewrite this, x to the 5th is on the top because it's still positive, y on the bottom because it was negative. I'm not going to put a 1 up there because you don't need to put an exponent of 1. And then you have z to the 4th. And so this would be our answer. Other ones, x to the 10th minus x to the 4th will give us x to the 6th. Next one, x to the 9th minus a negative 2 gives us x to the 11th. And the final one on this slide, we have x to the 1st minus 2, y to the negative 3rd minus 2, and z to the 5th minus 1. Simplify it, I have x to the negative 1, y to the negative 5th, z to the 4th. To remove my negatives, I need to have the bases flipped. So I have x in the denominator, y to the 5th in the denominator, z to the 4th stays in the numerator. Now some application problems. How many times more intense is the sound of a rocket liftoff at 10 to the 3rd watts per square meter than that of a regular speech at 10 to the negative 7th watts per square meter? Hint, we need to write it as a ratio. So if we look at that one, we're going from a rocket liftoff, 10 to the 3rd, over 10 to the negative 7th. And when we're dividing like bases, you take the base and you subtract the two exponents. So 3 minus a negative 7, which would give us 10 to the 10th power. And we would simplify that. And so we would have it would be 10 billion more times intense than the regular speech. Next one, a kilometer is 10 cubed meters. A millimeter is 10 to the negative 3 meters. How many times larger is a kilometer than a millimeter? So to solve this one, we would set it up the same way. We're going from kilometers to millimeters. So kilometers to millimeters. So when I simplify this, divide like bases, I have 3 minus a negative 3, which would give us 10 to the 6th or to simplify that, it would be 1 million times larger, or 10 to the 6th times larger. And the last question, how many times more intense is the sound of a jet liftoff at 10 to the 1st watts per square meter than that of a vacuum cleaner at 10 to the negative 5th watts per square meter? Express the answer in exponential and standard form. So I start with the jet liftoff, which is 10 to the 1st divided by 10 to the negative 5th. And so this would be 10 to the 1st minus a negative 5th, which would give us 10 to the 6th. That's exponential form. Standard form, we'd write the whole number out, which would be 1 million times more intense. So that is our lesson on simplifying expressions with negative and zero exponents.